1950 Assam earthquake happened to result in deadly landslides that blocked the passage of Brahmaputra for a while, resulting in floods. Japan is also not a even topography. It's not a monotonous topography. They do have the mountains and everything. High altitude region unki paas bhi hai. There is a lack of reliable precursor to predict. So now these glacial lakes, if there is more amount of water that is coming, will these naturally formed dams or the debris dams, will they sustain? They will break. There is significant amount of melting of the permafrost region. This particular Himalayas is called the third pole. Also, by reducing the long-term water supply, it will impact the agriculture, and it shall also impact the drinking water, hydroelectric power projects.
What sets AIR2 and AIR3 apart in UPSC CSE 2024? They didn't wait to feel ready. They started smart with the GS Foundation course at Vision IS Delhi. Structured learning, focused current affairs, real mentorship, test feedback that actually helps you grow. This course isn't just about study hours. It's about direction, clarity, and the strategy toppers trust. Start strong. Start where toppers started.
UPSC preparation is not just about reading books or watching online lectures. It requires personal guidance, real discussions, and structured practice. This is where offline mentoring makes all the difference. Unlike online learning, where doubts often remain unresolved, offline mentoring offers direct interaction, real-time feedback, and an environment of discipline and competition. One-to-one sessions help students get tailored advice, strategy corrections, and focused improvement. Every aspirant has different strengths and weaknesses. Personal mentoring helps address them effectively. Ground discussions sharpen analytical thinking and help students develop a multi-dimensional perspective on issues crucial for prelims, mains, and interview. Elocution sessions help in personality development, clarity of thought, and confidence, essential for UPSC interviews. Test writing is the most crucial part of UPSC preparation. It helps in time management, structuring answers, and improving content quality. Offline mentoring is not just about teaching. It's about grooming future officers with the right guidance, discipline, and confidence. So if you are preparing for UPSC, make sure you have the right mentor by your side.
So now, here we are looking at one of the topics that is quite, we can call it as, like an interesting topic. Okay, especially in terms of like the prospects in your exam, there is higher chances for these questions. Okay, and if you ask me, looking into the previous year questions, okay, we will also discuss a couple of questions that is written by toppers. Okay, I'll bring you the toppers copy here. I'll show you how the questions of the critical minerals, how the questions on Himalayan crisis was handled by them. We'll look into that at the end of this lecture. Okay, so only thing is probably you'll have to bear with me for an extended hour. I mean, not complete hour, but half an hour. Okay, you'll have to bear with me for that. So I'm promising you one thing, it will not be a boring session. That will be the thing. Okay, yeah, that's a promise from my side. So now let's look at this. Like, okay, before venturing into this, I'll give you what is the importance of this. 2013, the pattern changed. Since 2013 till today, matlab 2024 mains, okay, the questions on landslides, earthquakes, and also unsustainable developmental practices, if you collate the number of questions, it will cross more than 10. Okay, just landslides was asked both in your GS paper 1 and GS paper 3. Just landslides. Very simple example, how crucial this topic is. 2022, you take up the paper of GS1 and GS3. In both the papers, you have a question on landslides. Both the papers, 2022. Okay, 2022 or 2021, either of this. 2018, there is a question. 2017, there is a question. 2013, there is a question. Only landslides I am speaking about, not earthquakes. Okay, and ask me about the prelims. No competition at all. Every, like, at least I can show you close to 6 to 7 questions in the past 10 years. Okay, so understanding this amount of significance for this topic, we need to prepare the possible questions for interview also, right? Your holistic preparation will be there always. It's not that segmented. I'll clear prelims, iski baad mains, iski baad interview. ऐसा नहीं चलेगा, ठीक है? So you have to build the concept clearly. So let us look at this. Now, look at this particular topic, Himalayas in crisis. Why? Tectonic risk, landslides, and unsustainable development. Okay, so it's a looming catastrophe and there is a need for urgent action. Okay, why is it a looming catastrophe? What are these tectonic risks? What are the landslide risk? And how are these unsustainable development happening in that region? इसके बारे में हम देख लेते हैं इस सेशन में, ठीक है? So now, firstly, let us start with this. Now, specifically, whatever you do, okay, there are the aspects of geological phenomena, there are the aspects of anthropogenic phenomena in this particular Himalayan crisis, correct? Like you see tectonic risk, there is both anthropogenic as well as geological, right? Let me give you a simple aspect. Tectonic risk, it's an active plate boundary, right? The plate of India is actually subducting below the Eurasia. It's not melting, but it is resulting in doubling of the crust and all those you must have studied in geography. Okay, now as the plate, one more thing, as the plate is going below, what is the rate? That's the question. Okay, so if you look at that way, see, Indian plate is going beneath the Eurasian plate at almost 4 to 5 centimeters every year. It's not small. It's not at all small. Okay, so like the maximum you can see is almost 12 centimeter that is run by the Pacific plate. Otherwise, this is 4 to 5 is almost half of it. Is that clear? It's of course a bigger number. Okay, and as you can see, this particular like scenario is resulting in accumulation of stress in the rocks and periodic release of it at few points, and still the storage of that stress since a century at several other places. Now imagine, century, 100 years, stress accumulated in the rocks. Now when it releases, what will be the magnitude? Able to imagine? Right? Now, magnitude to chhod do. Abhi intensity ki baat karte hain. Intensity batao. Like for example, if the magnitude is 8 plus, Himalayan region, will it impact Delhi? Yes. Yes. Delhi is zone 4. Right? Now imagine, Delhi mein kitna structure, infrastructure is standing by the norms of resilience. Can you name? Except for our parliament, Supreme Court. Can you name something? Rashtrapati Bhavan or a few other? What about common public? Got it? समझ में आ रहा है? You are able to visualize the intensity, right? So now, if not just this, we are speaking about the impact on humans. Now let us speak one more thing. Hum tourism, like if you want to go on a trip, where would you go? Himalayas? Yes or no? Right? The entire belt of North India, right? The Indo-Gangetic regions, looks at Himalayas as a nearby destination for tourism, so frequent visit. The entire belt of peninsular India looks at the Himalayas as a luxury trip. They will also plan, they will also come here. Internationally, because of the magnanimity of this Himalayas, it attracts the tourism. अभी इतना tourism handle करना है तो ठीक है, infrastructure development होगा. Of course. Yes, of course, that is also there, right? So tourism encapsulates everything. Okay, so it can be the aesthetic tourism, it can be the spiritual tourism, it can be the medicinal tourism. Okay, several other things. Rishikesh is a spiritual as well as medicinal, right? Yoga, where do you want to classify? It's your wish. I will call it spiritual. I would call it healing, right? So Rishikesh, again in the Himalayan region, right? So now whatever it is, when tourism increases, infrastructure increases. When infrastructure, human footfall increases, environmental degradation increases. Correct? So on the other hand, like all these are the threats that can potentially break the socio-economic factors, disrupt the socio-economic factors. Correct? Okay. Now let us look at this. If we are looking at this, then we need to understand how to mitigate or how to fight these challenges, mitigate it and adapt for future, better future. That is something we need to look at. Is that clear? So let us start with that. So yes, here we go. This was the background of the Himalayas, which I told you. Okay, I was supposed to play this slide, but that's okay. Next. So now, when you look at this particular Himalayas, right? Let us go a little technical into this now. Firstly, when we speak about Himalayas, Himalayas is the symbol of dynamic geological setting. Accepted? इसका meaning क्या है? There is extreme dynamics of the geological events in this region. Correct? You speak about endogenic or exogenic. Both are there. Right? Both are there, active enough. Right? Young fold mountains of the world. Right? So this is the thing. So when was the last time you heard about the measurement of, the height of the Mount Everest? How much is it? How much was it? You must have heard about 8848. But now today it is 8849. Okay, 1 meter increase. Okay, so you see the difference. Correct? So that dynamic it is. Now, like you can see, that entire Himalayan region, the Western Himalayas, Central Himalayas and the Eastern Himalayas, the entire actually represents, okay, the entire actually represents this entire region, okay, starting from Western Himalayas, Central Himalayas and the Eastern Himalayas, okay, you can see this entirely makes the main Himalayan thrust. Is that clear? It makes the main Himalayan thrust where significant amount of the seismic energy is released in periodic basis. Okay, so this is something you can see. Now, generally, if you look at the historical cases of the seismic energy and also the paleoseismic studies that is conducted by the researchers, there are numerous examples with 8+ magnitude of earthquake in this region. Okay, so with 8+ magnitude of earthquake, you can look at this. So like you can see, this was the most devastating earthquake that happened in 1505, that is called Lo Manthang. Okay, similarly Kathmandu 1833, 1934 here, and Darjeeling में भी हुआ था, and here, so you can see Dehradun ke paas bhi hua tha, Kangra mein bhi hua tha. Okay, all these are 8+ magnitude earthquakes. Okay, so now when you look at this here, what you can see, very simply observe something, is that there are gaps between these points. Gap, here again gap, correct? Here again gap. So there are gaps. These are called seismic gaps. Okay, so when you look at this here, the entire Himalayan segment that is going beneath is having the entire Himalayan, the entire Indian plate that is going beneath is having the Himalayas, but where it releases the seismic energy is in segments. Is that clear? Okay, so now like that segments are receiving, but where it has not received, that is the symbol of a seismic gap. That means their accumulation of stress is happening. Is that clear? Their accumulation of stress is occurring. Okay, able to connect? Should I repeat? Understood? Okay, now when you look at this, now one important factor, let me tell you. If this is Eurasian plate, this is Indian plate, this is going below it, but it's not going like this, it is broken as it is going inside. Samajh mein aa raha hai? Did you understand? It is not going like a complete plate. It's after going below, it's breaking. Abhi batao. That means the seismic activity will be exaggerated. Okay, so there is significant risk of this delamination of the plate. Okay, matlab split of the plate. Okay, so like under the Tibetan plateau, as the Indian plate goes, you see there is complex accumulation of stress that can be the potential high magnitude earthquakes in the future. Is that clear? And further, what you can see is that there is interconnected seismic events all across the Himalayas. One place there is a seismic event, then immediately it can trigger one more seismic event in the connected main thrust fault region. Is that clear? So this is something that you can, matlab idhar kuch earthquake ho gaya, isse related it can also happen here, it can happen there, it can happen further. So that is how it is interconnected. Okay, so that is something that you need to remember. Okay, now I was speaking about the seismic gap. Okay, see, when I say seismic gap, see this entire fault line, this entire main thrust fault line is accumulating stress, yes or no? Because the Indian plate is actively going below, it is accumulating stress. But if you look at the places along the seismic gap jo bhi hum address karte hain, there is no earthquake since at least a century. Okay, like look at them. Last time when did it happen here? 1905, 1803, 1866, 1833, 1934, 1897. That means 1950 Assam. That means, could you please imagine like what happened to that energy? Did it dissipate anywhere? That means it is accumulated in the rock layers. Correct? Imagine 4 to 5 centimeters every year, accumulation of that stress, multiply it with a century time period. Got it? Matlab, the plate, even if you take 1 century, okay, the plate has moved more than 2 long scales. Right? 30 centimeters ko hota hai ek long scale, 2 long scales, more than that it has moved. What happened to the energy? It is there in the rocks. It is there accumulated in the rocks. Okay, so when you look at this now, there is this particular gap that is called Central Himalayan Seismic Gap. When this bursts out, imagine the magnitude and imagine the amount of the consequence it can result in. For the entire of the Indo-Gangetic Plains, Himalayas and surrounding regions. Samajh mein aaya? Able to make that imagination? Gives you shivers, right? So that is something you can look at. Now, see, basically, let us look at some of the historical activities of this particular region. Okay, so okay, let's look into that. So before that, see, I would like to play one video before that. We're not going to look into the entire video, but specifically कुछ points दिखाता हूँ मैं
Taking
अभी.
beauty of the Himalayas, a range that cradles Everest and stretches across multiple nations, lurks a silent, unseen threat.
Okay, look at this.
Historical seismic records indicate that the Himalayas have experienced massive earthquakes roughly every 100 to 300 years, though not uniformly across the range. Among the most devastating was the 1505 Low Mustang earthquake, which struck the central Himalayas and is believed to have been a magnitude 8+ event. The 1803 Garhwal earthquake followed, affecting the Indian state of Uttarakhand. In the 19th and 20th centuries, the 1833 and 1934 Bihar-Nepal earthquakes caused widespread devastation in the Kathmandu Valley and parts of northern India. The 1950 Assam-Tibet earthquake, the largest recorded in the Himalayas, with a magnitude of 8.7, triggered massive landslides, altered river courses, and claimed thousands of lives. More recently, the 2015 Gorkha earthquake in Nepal killed nearly 9,000 people and displaced millions. Notably, it did not rupture the surface, leaving a significant portion of strain still locked in the crust. Each of these events serves as both a warning and an insight. While they release accumulated tectonic stress, they also highlight the uneven and incomplete nature of energy discharge along the Himalayan fault system. Seismologists have identified multiple segments along the Himalayas where large earthquakes are overdue, based on the time elapsed since the last known rupture and the rate of tectonic stress accumulation. The most notable of these gaps lie in the central and eastern Himalayas, particularly in regions of western Nepal, northern India, Uttarakhand, and Himachal Pradesh, and parts of Bhutan. The concept of an overdue earthquake does not imply a precise prediction, but is rather a probabilistic estimate. By studying paleoseismic data, evidence of prehistoric earthquakes preserved in geological formations, scientists can estimate recurrence intervals. In many of these seismic gaps, those intervals have already been exceeded, suggesting that the conditions are ripe for a large rupture. Recent advances in satellite geodesy, particularly...
Let us hold it here. Okay. Okay. So, did you look into that video? What was it saying was very clearly that it is accumulating that much of stress. And the researchers have identified that much of stress in the rock layers, right? Especially in the western Nepal and also especially the central seismic gap region. That's what we are looking at the picture. Is that clear? Now, when you look at this, where can you have the possible high magnitude earthquakes in the future? One, central Himalayas. Okay, the entire central Himalayas is accumulating the ongoing strain, and it can accumulate and someday result in a deadly potential earthquake. Second region, Assam Himalayas. Okay, there also you can experience a high risk tectonic complexity very soon. Okay, and next, Kashmir Himalayas is also a part of it. And further, nevertheless, Himachal Pradesh. Okay, if you look at Himachal, now consider Himachal, the deadly stress that has been accumulated plus the human activities that is going on there. Right? Can you link it? Yes? Okay. So, 1950 Assam earthquake happened to result in deadly landslides that blocked the passage of Brahmaputra for a while, resulting in floods. A is equal to B is equal to C. Got it? What? Earthquake, landslides, blocked the Brahmaputra, floods. अभी बताओ कौन सा डिजास्टर को इलाज लेकर आए अभी? Which disaster are you bringing the remedy for? Right? So, it should be an approach that you will understand later. We'll look into it. Okay. So, now, to discuss like specifically what exactly is the vulnerability of the existing infrastructure of the of the region to earthquake is very important, because what you can see is Japan is also not a even topography. It's not a monotonous topography. They do have the mountains and everything, high altitude region unki paas bhi hai, but their infrastructure resilience brings down 99 out of 100 cases, right? Yes or no? To be very specific, Japan receives at least 1000 earthquakes per year. Okay, at least 1000 earthquakes per year. Then think, it should be like breakfast time one earthquake, afternoon lunch mein ek earthquake, like night dinner ki pehle ek earthquake. That is the magnitude, sorry, that is the frequency of earthquakes. But still, why don't we see so much of, like, the, what do you call it, as the damage or like loss of life, environment? That is infrastructure. Then where are we lacking? The Himalayan countries, where are we lacking? That we need to know. So, firstly, there were certain studies conducted in Uttarakhand. Okay, in Uttarakhand, what was seen, 90% of the existing buildings that is related to fire and emergency services, police, hospitals are going to be unusable after an earthquake. Okay, these are critical infrastructure, to be very specific. So if it is not usable after an earthquake, then what about other buildings? Abhi batao. Right? Able to think about it. Okay, next. In Nainital and Mussoorie also there was a research which said if the earthquake epicenter is close to these settlements, then you can see all the buildings, 99% of the buildings will collapse. Okay, next. There was rapid visual screening methodology put in Kashmir Valley. Through that, what was understood is that the entire low middle income areas or settlements in the Kashmir Valley will not survive after a deadly earthquake. Low middle income areas. समझ में आ रहा है? Able to understand? India is made of low middle income people, right? So now, so basically what you can see from this is that the infrastructure damage is not just to the roads and bridges, but to the infrastructure that is also these houses and also fire stations, police stations, hospitals and several others, which actually serves the relief and rescue mechanism or post disaster management. समझ में आ रहा है? Okay, so now what exactly contributes to this vulnerability? That is something we need to look at. Okay, this is the same thing we are looking at now. What exactly contributes to the vulnerability? First thing, the construction quality is very poor. Okay, poor construction quality, especially in the rural areas where they are not constructing the infrastructure made to be resilient to earthquakes. They are not doing it. Is that clear? So government should first focus on that. Okay, second thing, lack of maintenance. Once the infrastructure is constructed, be it roads, be it bridges, be it the houses, we don't maintain it or we don't ensure periodic maintenance of it. Correct? Yes or no? At least the government buildings should be done. The public properties like the bridges, roads should be done. Correct? And apart from that, the compliance to the safety standards is abysmal, complete low. Okay, so like whatever the bridges and all those, not the new ones probably, but the ones which are not maintained are also not compliant to the seismic resilience. Is that clear? So these are the ones. Now, like apart from this is something that is actually exaggerating the situation in that region. Okay, apart from this, next, if that is the case, can we do something at the source, like predict the earthquakes? That is something we need to know. So let us look at it. See, first thing, it is very difficult to understand this complex tectonic activities that is occurring. Why seismic gap? If we knew why seismic gap, I would have explained it during the concept, right? We do not know why seismic gap. Okay, it is accumulating, yes. Why is it accumulating? No idea. We are still at the research level handicapped. Not just us, you bring anybody from the world, they cannot identify. Okay, so basically there is the complex strain accumulation that why at place, see the land has to rupture, that means it is releasing the energy. If there is an earthquake of scale 6, scale 7 but no rupture, that means still there is energy, wait for the next dose. Hmm. Ha. Yes. Yes. But now, like for example, you can identify the causes. Okay. See, I'm not saying we do not have it. I'm saying we have it, but limited knowledge. Okay. Now you can identify the cause of the earthquake. That's how you could, in the video also it showed, we could actually see the stress being accumulated. But tell me, when will it release? Where will it release? That's the question. Okay. So that's what we are looking at. Okay, so basically here that is something you will see. And second thing, let me bring one more aspect here. The amount of stress accumulated versus the magnitude that you are seeing is not proportional. It's not at all linear. See, if the amount of, like let us say this much pressure is accumulated, let us say 10 units, then the magnitude should be 5, but the magnitude is 3. समझ में आ रहा है? And if the amount of units of stress accumulated is 1000, the magnitude should be 8 and rupture of land, but the magnitude is 5, no rupture of land. So what you can see is there is complete non-linear behavior between the factors that actually are responsible for earthquake occurrence and what you are experiencing. Is that clear? So that's where we are handicapped again. Okay, and second thing, you cannot monitor where exactly the focal point can be. Is that clear? You cannot pinpoint and tell that this is the place where the next earthquake will occur. That cannot be done. Okay, इससे क्या हमको समझ में आता है? We are able to identify there is something, but we are not able to identify where is that something. Right? Got it? Exactly. Okay, so see, I'll tell you one thing. Most of the knowledge that we know stops at a point from where even the most scholarly person of the field thinks there is the role of the God. Okay, but that's a different perspective. Let us bring it here. Let us come to this point. Okay, yeah. So next one, when you have to look at the identification, or let us say you want to actually predict an earthquake, there are some factors that we can look at. Like for example, like you know what is foreshocks and aftershocks and a main shock, right? So basically everybody knows it, right? Okay, so basically when you have the foreshocks, you can predict a main shock, but sometimes there are swarms. Then how, then is it actually a good variable or good precursor that we can rely on? No. समझ में आया? Okay, and can you take it for granted saying that there will not be a main shock? No, it spans for months. Foreshock spans for several months. So abhi we are handicapped in that assessment. Correct? Second thing, also you can say, like for example, we look into animal behavior. Correct? That's also one of the sort of a precursor through which, by looking into the animal behavior, we can predict the earthquake. But now the question comes, what if the animal behavior is not predicting correctly, accurately? Then it's a false alarm, right? It's a false alarm, correct? So now that's what I'm saying, the predictions are not accurate. Is that clear? So there is a lack of reliable precursor to predict. Okay, and apart from this, you can also see we have limitations in the current technologies also. Okay, we actually have the limitations in current technologies. Like for example, so far I was telling you, and we have seen it in the video also. Scholars assessed what is the reason, scholars assessed what is the magnitude, scholars assessed that there is strain accumulation and there is, like, central seismic gap where there is no earthquake since a century. And they are saying this is the region, West Nepal, this is the region, West Nepal, Assam, Central Himalayas, Himachal Pradesh will receive extreme amount of, like, frequent high magnitude earthquakes. But tell me when? Where in Western Himalayas? Ye batao mujhe. Where in Himachal Pradesh? You tell me this. Now that shows our handicapness with respect to the technology. Correct? Samajh mein aa raha hai? Okay, so what you can see this is, there is complete uncertainty with respect to we depending on our technology. That is the solution. Okay, that is the solution. That we'll look into it later. Okay, so also, like, another thing, like for example, chalo, let us say with the knowledge we have, okay, like for example, let it be the animal behavior, or sometimes even the water level in the well, that is also taken for assessment. Okay, it can be the water level in the well, or it can be something like the animal behavior, or it can be something like for example, let us say the foreshocks. Considering these, now if you want to take a step, okay, what will be the first thing? Evacuation. Evacuation करने के लिए economic expenditure तो होता है ना, right? So there is significant amount of economic aspects, expenditure. ये तो छोड़ दो. If I am evacuating you from this place, आपका livelihood क्या होगा? Correct? Your livelihood is at stakes. That means that is also an economic loss to the GDP. Okay, expenditure is an indirect loss. Now you tell me, after all this, there is no earthquake. Okay, after all this, you are the district magistrate, and after all this, there is no earthquake. Then you tell me, will the public have, like, trust on the government? No. So that is like another aspect where your credibility is questioned. समझ में आ रहा है? So that is another challenge in the earthquake prediction. And चलो ये इसकी बारे में हम सोच के, like, we have not taken the step and there is a deadly earthquake, then also we have economic loss, also we have human loss, ecological loss, infrastructural loss, बहुत ज़्यादा है ना. So that is the dilemma, or like something that is like a challenge. Okay, apart from this, so what should we do? What should we do? Like you said, one, bring in machine learning, bring in artificial intelligence. So bring the data from hydrological, meteorological, geological factors, okay, and then accumulate it, use the supercomputers, understand what can be the near accurate thing, if not accurate, right? So use these techniques, use remote sensing techniques. These are something that you can apply. Second thing, also put good amount of investment in research, development, and also understanding the physics of earthquake first, right? So this is something that we need to look at. Okay, so see, I'm not saying we're not doing it, I'm saying do it more. Okay, so that is something you need to look at. Next, that was our first section, earthquakes. Okay, now we understood the vulnerability of earthquakes, the dynamics of the geophysical setting of that region. Okay, and what is the vulnerability of India, what is the vulnerability of in total the mankind in the Himalayan region with respect to earthquakes. Now let us look at the next one. Okay, this is about the landslides. Okay, now this is about the landslides. Firstly, let me ask you one simple thing here. when we are actually looking at the landslides. Okay, so what are landslides? Anybody? Can you define landslides? Yes, sir. Okay, yes. Can you tell me, are there any types of landslides? No, I'm not asking causes. I'm asking types. See, what is landslide according to what he said? It is the portion of the earth material that slips down the slopes. Correct? So, anything can be the causes. As you said, man-made or like, the geological. But you tell me, what are the types of it? You must have studied this. Yeah. Any idea? That's it, ma'am. Or you, sir? Okay, chalo. हाँ. Okay. Geography खत्म हो गया? Okay. Okay, chalo. Let me tell you this. Rockfall, solifluction, debris flow, avalanches, right? Or glacial lake outburst floods, right? All these glacial lake outburst flood, we'll look it as a cause. Okay, but otherwise, like, matlab, like you have the mud flow, okay, solifluction, all these are the examples. Okay, so now what do you mean by landslide? Landslide refers to a portion of the earth material that is subjected to downward slope movement. Is that clear? If it is the boulders and the rocks, that is rockfall. If it is the mud that is saturated with water and flowing down, that is mud flow or solifluction. If it is actually any other debris where mud composition is relatively less, then it will be debris flow. Okay, and if it is actually something like the unconsolidated ice or unconsolidated snow flowing down the slope with the earth material just below it, okay, that is avalanches. Okay, what you can see is there are several types of landslides. Now you tell me, which of them are possible in Himalayas? Is it all of them? Yes, very simple. How? Let us take few examples. Avalanches, is it possible? We had one in Sikkim recently. Okay, so avalanche is possible. Second one, mud flow is possible. Cloudburst तो हो रहा है ना इतना ज़्यादा, और हम तो ये डेवलपमेंट के नाम पे एनवायरनमेंट डिग्रेडेशन बहुत अच्छे से कर रहे हैं हम, right? So that means you tell me, when there is a cloud burst where there is deforested slopes, now the mud will mix with the water and flow down. So can we have solifluction, mud flow, debris flow? Yes. Landslides, yes, the huge chunk of the land, right? So rockfall, yes, that is also possible. Earthquakes hai, okay, itna physical weathering hota hai, the mountain rocks are broken into boulders. Now there is an earthquake, roll down, that is rockfall. Okay, it has occurred recently in a couple of years back. Okay, so this is something that you can see. Yes, to an extent, yes. Yes, it adds on to the vulnerability. Okay, so now looking at this much of understanding what exactly is a landslide, now let me tell you some examples from the Himalayan region where you have extreme deadly landslides and other, like rockfall or something like this. Look at this. This is Malpa landslide that occurred in 1998. Okay, so what happened was, you can see in the Malpa landslide, so in the region, you know what is Malpa? First let me ask you that. Don't look into the picture. First tell me that. Don't read the picture. Tell me that. What is Malpa? It was a small settlement. Okay, which you are not heard of because 98 में collapse हो गई. पूरा landslide vanished it. Okay, now you can look at this picture. Rain loosened a rocky mountain 3000 feet above Malpa. Malpa was somewhere here. Okay, rain happened to loosen it. An avalanche of rocks and water rumbled towards the village, rolled down. Complete Malpa is gone. It's not there today. Okay, so this is Malpa landslide. Is that clear? Okay, so now you tell me, is this something to be taken easy? No. Okay, now next. You must have heard about this 2021 Chamoli district, right? If you look at Chamoli district, that landslides that happened, see, many people portrayed it as the glacial lake outburst flood. But trust me, it is not. Okay, it is not a glacial lake outburst flood because there are no significant glacial lakes in the region. Is that clear? There are no significant glacial lakes in this region. So what you can see is, see, so there is actually a peak in this region that is called Ronti Peak. You can see on the picture. Actually, there is a peak in this region called Ronti Peak. Okay, so this is the flow path that is actually, sorry, this is where the Ronti Peak is, and this is the flow path that is actually showing how the water flew. Is that clear? Now, if this is actually the region where you can see that the glacier happened to affect. Okay, so what happened in this region? See, along the Ronti Peak, there is this ice and snow covered bedrock. Okay, so here the entire rock happened to subside, and the energy that was induced in that subsidence of that rock, or like falling of that rock, that energy triggered melting of this glacier. Is that clear? That energy triggered the melting of this glacier, and there is proper break in this rock and the glacier. Now, as it fell onto the ground, this was a massive flow of water because it melted the glacier. It was a massive flow of water. Now imagine, was that the first landslide? No. So previously, when there was landslide, okay, so that previous landslides happened to accumulate some debris on the path, correct? This debris would have over the time dammed some water or basically ice. Okay, now this fall and the amount of glacial melt, the volume of water broke those debris. Okay, that was previously accumulated. It carried water and ice from there also. Now the volume peaked, and that resulted in this, where it broke the Tapovan hydroelectric power project, it broke the Rishiganga hydroelectric power project. Okay, and starting from here, several kilometers down, it affected. Samajh mein aaya? So this is what happened in this particular region. Now the question comes, why did this break? Okay, this landslide occurred because just a couple of days just a couple of days before this incident, there was a cloud burst and also strong western disturbances that happened to result in heavy precipitation, loosening it. Okay, loosening it, and also that increased the chances of floods in the downstream. Samajh mein aaya? Able to connect the links? Now you tell me, is it purely GLOF? No. Got it? Is that clear? So this is one another example. Now on the other hand, you know this very well. Okay, I chose this picture because look at the depth of it. You see there is fall in it, right? And also look at it, still it has the depth you can see from the picture. This is from Joshimath subsidence that happened in 2023. Okay, see, Joshimath subsidence, to understand this case study, one important thing I'll tell you, there were some critical findings that happened to come from these studies by major organizations and institutions. Let me tell you, because you should know the studies, how authentic it was. Wadia Institute of Himalayan Geology, that is in Dehradun, that happened to look into the Himalayan geology, rock structure. National Geophysical Research Institute, this is in Hyderabad, it looked into the geophysical research of the region. National Institute of Hydrology, Roorkee, so they looked into the hydrological aspects. Indian Institute of Remote Sensing, Dehradun, they looked into the remote sensing aspects and what happened before, what happened during, and what is going to happen future. That was something they were looking at. And Department of Earthquake Engineering, IIT Roorkee, they were looking into the earthquake engineering components. And Geological Survey of India, they conducted the surveys. And Central Groundwater Board, they looked into the groundwater resources. And Central Building Research Institute was looking at the kind of the buildings that is present in that region. Okay, so, and all of their work resulted in one conclusion, only one conclusion. That is, I mean to say, a set of 5 conclusions. That is, between 2010 and 2020, between 2010 and 2020, in one decade, you can see the built up area in Joshimath increased by 100%. Okay, increased by 100%. Now, 100% increase, मतलब अभी सोचो इनका वाटर रिसोर्सेस के ऊपर, सैनिटेशन के ऊपर, सैनिटेशन इंफ्रास्ट्रक्चर के ऊपर कितना स्ट्रेस लगाया है, right? So this is another thing. Okay, next, apart from that, now there is also one more thing you need to know. Joshimath is not a hill, is not a mountain. It's a debris that had accumulated from past landslide. Okay, it is a debris that is accumulated by the past landslide, and what you can see is in that, on that particular Joshimath, okay, there had been, like, you know, the rivers passing at the sides of this debris, and what you can see is the exaggerated rampant construction that occurred in Joshimath also like resulted in like blockage of subsurface water channels, because when you put weight up, it actually compresses the pores, it will not let the water flow, right? It compressed, so it blocked the water flow. Next, apart from that, what you can see is basically the wastewater discharge and also the infiltration of the rainwater and the exaggerated melting of ice due to the climate change. All these happen to put pressure on this particular debris. Is that clear? So where the subsurface drainage happened to like take the pressure, okay, and you can see that pressure resulted in causing land subsidence. Is that clear? Moreover, you can also see there is also significant, I told you just now, the weight that is put on the debris. Iska very beautiful study conclusion was where there is settlement in Joshimath, where there is greater habitation and settlement, there the subsidence is seen, not where the scarce settlements are there. Samajh mein aaya? Okay, that means where sparsely populated region is there, there you did not find the cracking or subsidence. Where there is dense settlements, there you have identified this. Is that clear? So now also one more thing is that, you know, there are several natural springs in this region. Those were blocked by uncontrolled and unprecedented development of human infrastructure. Okay, human based infrastructure. Okay, so that is where the sudden groundwater release has or else let us say the sudden groundwater release and the pressure in the pores of the debris resulted in landslides. Is that clear? So that is something you can see. These are the 5 takeaways from the research that was done by those premiers. Okay, so now on the other hand, what you can see is basically here what exactly are the causes of landslides. Of course, infrastructure load, as I have told you already, right? And second thing, like when there is water below, the greater amount of resource extraction will create the pressure difference that will result in collapse. Correct? Okay. Now when it collapses, the pore pressure is also taken into consideration. Okay. Next, plate slipping because of the tectonic activities. See, this is in general I am speaking, not just Joshimath. Okay, so tectonic movements in that region can also bring this. And most importantly, when like isostatic movements, you know what is isostasy? Okay, chalo, let me tell you. Which is the continent that is below the sea level? Which is the continent that is below the sea level? Anyone? Is there any continent below the sea level?
Preparing for the UPSC Civil Services examination demands strong preparation across all mains papers. And when it comes to scoring well in the mains, your optional subject plays a crucial role. A good performance in your optional paper can be the difference between just qualifying and securing a top rank. To help you build a strong conceptual foundation and improve answer writing, Vision IAS presents the Optional Classroom Program 2026, available in both live online and classroom offline modes. Subjects offered: Geography, Sociology, Political Science and International Relations. Batch starts from 20th June, 2 p.m. Physics. Classes start from 15th July. UPSC CSE 2024 results are out and dreams have turned into ranks. Now you are asking, how do I get there? You've got the drive. What you need is the right guidance. Lakshya Integrated Mentoring Program 2026 by Vision IAS is your one-stop guidance program for prelims, mains, and interview. Smart, strategic revision for prelims and mains. Consistent mentorship with personalized feedback. Daily weekly schedule and practice targets. Custom test practice via Sandhan test series. Interview and personality test training. All of it structured to guide you, strategic to keep you focused, and designed to meet your evolving needs. New batch starts from 19th May. It's your turn now. Start strong with Lakshya Mentoring Program 2026.
Antarctica is the continent that is below the sea level because the plate, the lithospheric plate, is on a plastic medium or elastic medium or plastic medium bolte hain. That is the asthenosphere. It is actually floating on it. You put more weight on this, the plate will sink. Okay, you remove the weight, it will bounce back. This is called isostasy. Okay, now here the ice sheet, okay, that was here, that made this sink. Okay, now when because of the global warming, when the ice sheet is removed, it will uplift. Correct? समझ में आ रहा है? So similarly, what you can see is where it has sunk, okay, that can where it has uplifted, there it can sink because of the weight. Okay, that is isostasy. So in the Himalayan region, there is significant amount of isostasy that can also lead to the issue. Is that clear? So now next. So what causes the Himalayan landslides? Okay, so this is something that we need to know in detail. Okay, so the Himalayan landslides can be the result of natural as well as anthropogenic factors. When you look at the natural factors, this region is no less than any other place in terms of the heavy rainfall. Because of, like, heavy rainfall can be something, one, due to the monsoons, otherwise the cloudburst. Is that clear? The frequency of cloudburst has increased. The frequency of cloudburst, is it audible? Yeah, okay. The frequency of the cloudburst has actually increased in this region. Okay, why? Very simply because of the temperature and the pressure that is actually like changing with the climatic factors. Okay, and moreover, you can also see here, like earthquakes are very common. This can also result in landslides, correct? And there is significant amount of increase in the temperature that is resulting in exaggerated volume of water from the snow melt and glacials. Okay, now like for example, the earlier the debris would have actually blocked, and like in for example, the glacial melt water is coming down. As it is coming down, there is somewhere a small depression. In that region, the naturally dammed by the debris will hold the water. That is nothing but the glacial lakes. Okay, so now these glacial lakes, if there is more amount of water that is coming, will these are naturally formed dams or the debris dams, will they sustain? They will break. When they break, that is also responsible for excess amount of water flowing down and lubricating the subsurface clay layer and resulting in landslides. Correct? Okay, so similarly you can also see like the freeze and thaw cycles. Matlab freezing and melting cycles are not normal because of the climate change. Okay, so apart from this, you have several other aspects that is more anthropogenic. Okay, human contribution, deforestation, right? See, now you take Himachal Pradesh, you take Uttarakhand. Why do you have so much of that particular like landslides occurring every monsoons? Because there is significant amount of deforestation that has occurred. Okay, you can mark this event almost like 50 years before the Chipko movement. That was against the deforestation only, right? So since then till today, the pace and the quantity has not reduced but increased in terms of deforestation. Okay, next you can see unscientific road construction and slope cutting. So basically, if you look at this particular aspect, it can be the unplanned urbanization, it can be infrastructure development, or it can be road widening, construction, anything you speak about. What happens is here you tend to actually generate a lasting amount of debris, a vast amount of debris. So here this debris is not just created, but also by cutting down the slopes, you are destabilizing the slope. Okay? So when you do this, the water flow through this region is easily transporting the debris down the slope. Okay? That is nothing but landslide. Yes. Hmm. I shall surely answer it because some of the points are part of it. Okay, so let's complete it. At the end, you ask me the question if it is unanswered. Okay, I'll surely answer it. Okay, yeah. Next, so basically, like you can speak about this particular, landslides being very common because of unprecedented urbanization or this constructions and all this. Now, इसको तो छोड़ दो, इसको addition और एक point देता हूँ. Tourism की बारे में बात करना. Right? So this tourism, why is it not sustainable? Why don't we consider the Himalayan carrying capacity before allowing this much of tourists over there? Right? Greater the amount of tourist flow, greater is the amount of destruction you make to this ecosystem. And greater the damage caused, it will replicate in the high degree of landslides. Yes or no? Yes. Okay. So that is something. Moreover, we can look at significant amount of projects, especially the hydropower projects that is constructed. Okay. See, I told you the weight you put on the land, isostasy, correct? Now imagine the weight is dammed waters. Okay. The weight is dammed waters. Now does it also actually bring hydrostatic pressure induced isostasy? Right? This hydrostatic induced isostasy shall make the region vulnerable to earthquakes. It shall result in landslides when the dam breaks, or because we saw the Chamoli, right? So if such situations results in breaking of the dams, can we say that is also resulting in landslides further? Right? Yes or no? Okay. So like not just this, also to add, there is significant change in the land use plans. Okay. So we have cleared the forests. We have actually cleared the forest for agriculture, for logging, for development, and we have removed the entire vital vegetation cover that was protecting the part of the country from the landslides. Okay, so now by removing it, the soil has lost its natural strength, and you can see the natural strength that is lost has made it more susceptible to erosion and landslides. Okay, so this is something you can see. Nevertheless, one more thing, do we think the simple society's practice of shifting cultivation is sustainable? No, neither it is not sustainable. Okay, sorry, neither it is sustainable. Okay, so basically that clearing of land for agriculture and leaving it for years to rejuvenate will make the soil like become vulnerable. Okay, where the soil is completely disrupted, destabilized, and shall be prone to landslides. Yes, that is the shifting cultivation. Okay, in northeast we call it as Zoom cultivation. Okay, yeah. So these are some of the anthropogenic factors. Okay, so when you look at the unsustainable practices, okay, so unsustainable practices that is actually sort of looking in this region, these are the ones. Okay, so adding to it, I have told you these points also. Mining and quarrying is also very much high in this region, correct? So mining and quarrying is also very much high, blasting of it, all these are very common. Okay, look at this now. Let's analyze this. So starting from here, continent wise, if you look at the disasters, Asia has 41%. Okay, continent wise, if you look at, Asia has 41% of the world's disasters. Now within Asia, the landslides, so within the disasters, the landslides that is occurring on the continent, because underwater also there are submarine landslides, we are not considered about that. So the continental landslides that occurs across the world, 58% is in Asia. Okay, समझ में आया ना? अभी इधर आते हैं. Now you can see here southern Asia, okay, the South Asia has 34% of them. Okay, now let us come here. Within that, Himalayas has 89% of it. Now other regions is just 11%. Like for example, if you look at the southern Asia, we are not speaking about only India, we are speaking about southern Asia. In India also, you know that the vulnerability zones are Himalayas and Western Ghats, right? Western Ghats are also prone to these landslides. But now imagine the southern Asia, that means there are more places. Out of them still 90% is in India. Okay, so this is the degree of vulnerability that you can look at. Okay, this is the degree of vulnerability that you can look at in this region. समझ में आया? Okay, so next.
Are you still juggling newspapers, random notes, and endless PDFs trying to make sense of current affairs? Let's make your UPSC prep smarter. Introducing Digital Current Affairs Premium by Vision IAS, your all-in-one platform to read, revise, and write better every single day. Have a doubt from today's news or something in your syllabus? Just ask and get instant AI-powered answers that are concise, relevant, and completely aligned with the UPSC exam pattern. No more guesswork, no more confusion. Want to boost your mains writing skills? Practice daily with structured questions and get expert feedback to sharpen your content, clarity, and analysis, because writing well is winning half the battle. Need better revision? Use quick notes and highlights to save key points, mark important lines, and organize your current affairs in a way that actually works for you. And here's the best part, some of the most powerful tools are absolutely free. Daily news summaries from The Hindu, Indian Express and more, curated, filtered, and exam ready. Downloadable PDFs so your notes stay organized and accessible. Daily quizzes and MCQs to reinforce what you've learned and track your progress. A smart student dashboard to monitor your performance and stay on top of your goals. Whether you're just starting or deep into your prep, Digital Current Affairs Premium adapts to your strategy and makes every minute count. So why prepare the hard way when you can prepare the smart way? Visit www.visionis.in/current-affairs and start transforming your current affairs prep today. Because with Vision IAS, you don't just stay updated, you stay ahead.
What happened to this? Yeah, here. So these are something that we have already seen, like the footprint of unsustainable practices, right? We saw the reasons. इसमें हम ये बात already we have discussed about these points, right? So unplanned urbanization, hydropower projects, road construction and widening, tourism, deforestation, agriculture, mining and quarrying, right? These are something that we have already seen. Now, we understood what is earthquakes. We understood the Himalayan earthquakes. We understood the Himalayan landslides. And in the context, we did study the unplanned, urbanization, or let us say unsustainable development in the region. Now you tell me, let us look at this. A tectonic activity of magnitude 8 plus in the central seismic gap. We have studied the basics. Now we are applying it. Okay. The tectonic activity of, or a seismic activity of 8 plus magnitude in the central seismic gap can result landslides, because it is accumulating the energy, strain, stress. When it released, can it trigger landslides? Okay. Now these landslides can devastate the entire, like the human imprints of that region, right? Now next, let us start from here. We construct the infrastructure, roads, bridges, like houses, tourism infrastructure, sab kuch, at the cost of deforestation. Okay? We construct hydropower projects, we dam the lakes, and we actually put the water in stagnation at several places. Okay, so we are cutting down the forests, making agricultural lands and growing all the types of crops and everything, every economic development. Here, economic development, the question that you were asking, look at it. That when there is a rainfall, can it trigger a landslide? Yes, yes. When the landslides occur, is it not actually removing the mass from the slopes? When it removes the mass from the slopes, can I say isostatic imbalance? Now isostatic balance, imbalance की वजह से, are the rocks in this region destabilized? Can it result in tectonic activity? Yes. समझ में आया? So you start from anywhere, the other two will be rotating with it or driven by it. Accepted? Yes or no? Okay. So when you look at this, basically here it's a very vicious cycle. It is a loop, or it's a feedback mechanism, one amplifying the risk of the others. Is that clear? So very simply, like the tectonic activities, like take the earthquake that occurred in 1950 in Assam. I told you the example. A deadly earthquake resulted in landslide. That landslide devastated the settlements and everything that's on the slope, and the debris happened to block the Brahmaputra. Floods, again, it resulted in many of the houses and settlements to get vanished, and you saw the video where you saw several thousands of people died, right? So the idea, the thing was very simple. Those were not resilient to any, the infrastructure that was there was not resilient to any of the particular disasters. Okay, and it was not within the limits of the Himalayan carrying capacity. Okay, so that is something you can look at. Okay, so further, like poorly engineered infrastructure can of course like fall to rumbles, right? And apart from that, this in the seismic zones will be the potential destruction. And apart from that, you can see unregulated deforestation or excavations, mining, quarrying can actually result to landslides. Okay, and also see, the biggest thing in the unsustainable development is the lack of focus given to the traditional knowledge. Okay, so we look at them very less in order to achieve the short term gains. Okay, like for example, if you go to Bangladesh, if you go to some floodplains in the India only, there you will see the people happen to construct the houses in bamboo. Why? They happen to like make the farming on the bamboo sticks, like floating farming. You must have heard about it. It is famous in Bangladesh. Okay, floating farming. So they grow vegetables there. Okay, why? Even if there is floods, there is no loss. Okay, but that is a traditional knowledge. To achieve some short term gains, we actually take this very lightly. Okay, so further, what you can see apart from this, there is significant amount of melting of glaciers. There is significant amount of melting of the permafrost region. This particular Himalayas is called the third pole, or we can call it as the water tower of Asia. Southeast Asia relies on this. South Asia relies on this, Himalayas. Correct? So now imagine, itna jada like glacier and permafrost is actually melting down. Why is it called third pole? Because beyond the north and south pole, this is the region where you have highest amount of glaciers. Okay, like for example, Fedchenko Glacier, that is in Tajikistan, that is the largest one in this region, 77 kilometers. Then Siachen Glacier, India, it is 75 kilometers. Okay, we have such several others, Hisper Glacier, okay, and Bayafo Glacier. So like this, you have several glaciers along the Karakorams and several other places. These glacial melts, these permafrost lakes that is melting, shall actually make the region prone to landslides and more debris accumulation that can result in further landslides in the future, like you saw with respect to the Chamoli. Samajh mein aaya? Okay, so apart from that, so what you can see is, like, to address this, we need a holistic solution. Okay, where you have to consider the geological aspects, climatic aspects, and also the developmental aspects. It's not just one-handed, I look into one part, right? Because that's the reason I said the geological aspects because of the tectonic activities, and hydrological aspects because there is good amount of water resources from there, and climatological and weather related aspects because cloud burst, heavy rainfall, erratic rainfall, climatic changes are having an impact there, and nevertheless human development. Okay, that's where when you mix all of this, you get a multi-pronged approach. Okay, so there this approach should be backed with not just scientific understanding but human traditional knowledge. Okay, it should be like that. So that is where you can actually break that cycle. Is that clear? That is where you can break this cycle. Next, so is climate change a solution or a multiplier of this issue? Exactly, it's a multiplier of this issue because you see the role of climate change in the Himalaya is very high. Okay, like for example, if you see there is accelerated glacial melt that will break the glacial lakes, that will result in increased volume in the river flow. There will be increased the same way on the other hand, there will be increased instances of cloud burst, heavy rainfall, that will also result in the river flow volume increased. All these not just results in floods, but it shall also result in what is called as the landslides. Okay, so apart from that, see, now you can also see the extreme weather events had been responsible for the changes in this region and the crisis exaggeration in this region. Okay, so this is one another aspect. Adding to this, look at this. This is very brief period. I have not taken much of it. It's just July 8th to 12th, 4 days. Okay, just July 8th to 12th, 2023. So you can look at this. This is from IMD. Okay, Indian Meteorological Department. Look at this. Generally, this symbolizes normal, dark blue. Light blue is what it received. Kinnaur should receive 11.2 millimeters, but it received 115.9. How much? 935% increase. Kullu 30.7, but it received 280.8 millimeters, 815%. Solan 618%. Lahore Spiti 617%. Shimla 606%. Sirmaur is 591. Bilaspur 521. Hamirpur 381. Una 358. Chamba 338. Mandi 232. Kangra 141 times. Okay, you can see this is the impact of climate change. It's not raining there. As the statement says, when it rains, it pours there. Okay, imagine like I bring 100 liters of water and put it at one shot into a small space. That is what happens there. Is that clear? Samajh mein aa raha hai? Okay, it's a short duration but heavy rainfall. Got it? Now you tell me, will it not result in more weathering of the rocks, more saturation of the subclay layer, more of the landslides? Yes. Okay, so now what are the consequences of this? That is an impact on the life, okay, and environment. Firstly, there will be loss of life and livelihoods, right? You take the example of Chamoli disaster, you take the example of Uttarakhand floods, or like that is the same thing. Otherwise, like, you know, Joshimath land subsidence at the right time or near right time, it was like, you know, evacuated. But otherwise, you can take any of those examples where the Assam floods or several of them happen to sort of result in loss of life. Direct loss of life, indirect injuries and displacement of population. Correct? And moreover, you can also see there is significant destruction of infrastructure like the Joshimath. Correct? And also like there is environmental degradation. Himalayas is a biodiversity hotspot, isn't it? Yes. Then if any of these happening, will it not lose the habitat? Yes. When it loses the habitat, can I say the biodiversity declines? Yes or no? When the biodiversity declines, can I say the mountain ecosystem is not in a homeostatic equilibrium? When they are not in the homeostatic equilibrium, then will the climate change be tackled or exaggerated? Right? Simple. Planting trees sequestrates carbon. Deforestation releases soil carbon. Right? Matlab carbon dioxide basically. Now that is what is happening here. Release will exaggerate it. Okay. So apart from that, now as we consider this region as the water tower of Asia, any degradation of this or any vulnerability of to this region, can I say that shall result in immediate crisis and scarcity with respect to water? Yes. When there is more amount of water flow in the rivers, can I say it will alter the river systems also? Some paths can go dry and result in headward erosion, river capture, change in direction of the flow. Everything can happen. This can bring like impact on the agricultural lands, food security, geopolitical tensions. Yes or no? Right? Like for example, the Limpidura, Kalapani. Okay, so all these places are because of the Kali river change in the path. Similarly, take the Sasta region in, there is a place called Sasta in UP. Okay, that is because of the river Gandak. Okay, so like this you can actually see there is actually changes. Okay, moreover, you can also see there will be increased migration in the population. migration of the population, and that shall actually result in loss of livelihood, and that shall force the like eventually more people to migrate, and also this will change the entire socio-economic dynamics of the region. Correct? So this is something you can look at. Further, like you can also see that global implications. Okay, when you look at the global implications, okay, when you actually look at the global implications, what you can see is there will be, of course, disrupted hydrological cycle and water security. Like more the glacier melt, then of course then it will reduce the long-term water supply, right? And also by reducing the long-term water supply, it will impact the agriculture, and it shall also impact the drinking water, hydroelectric power projects, all these things. Now altered river flows will also do the same. It will result in increased floods also. And similarly, soil erosion and sediment transportation because of this water hydrological changes will result in more landslides. Okay, and also like we can say there is significant loss of biodiversity and ecosystem services. So what you can see is in terms of like species extinction can be seen, right? I explained about this. Loss of habitat and fragmentation of the habitat will result in threatening the survival of the species. Correct? And moreover, ecosystem degradation, right? So that is where when the ecosystem degrades, then the delicate imbalance that is brought will be reducing the possibilities of planet's resilience towards the climate change. Okay, so that means like a complete change in the scenario, like more the forest, more stable is the ecosystem, more it can fight and be resilient and adapt against the climate change, but otherwise it will break it. Okay, now regional instability and migration, I told you there will be increased amount of migration. Okay, and that will force the people to leave the places, creating humanitarian crisis, more of environmental refugees, right? And similarly, it can also result in social unrest because imbalance in the resources available, right? So that is also something you can see. And most importantly, it will amplify the climate change. How? See, deforestation, unsustainable land practices will increase the greenhouse gas emissions. Similarly, glacial melt, understand this point, glacial melt, when there are glaciers, there is good amount of albedo. You know albedo? Right. When there is glacial melt, there is more of heat trapped rather than sent out. Right? So that is exaggerating the global global temperature. Moreover, this will actually result in this global warming and all those will exaggerate in extreme weather events like the cloudburst, the intensified western disturbances, intensified monsoons. जहाँ पे आपको बहुत ज़्यादा बारिश होना है उधर कम होता है, जहाँ पे कम होना है उधर बहुत ज़्यादा होता है, right? So like that. So what is the solution? That is the question now. So what exactly is the solution? The solution is very simple. We have to prioritize sustainable development. इसका मीनिंग ये है, we have to respect the ecological fragility of that region. Okay, how fragile is this ecology? And accordingly, understanding the geological realities of that region, we have to adapt the development practices. You cannot go with single-minded economic development, but more ecological understanding, geological understanding induced sustainable development. Okay, so like for example, you have to conduct severe environmental impact assessments before coming up with any projects or anything. That is what it means. You know what is environmental impact assessment, right? So that is what it is. Okay, next, you have to invest in disaster preparedness and early warning system. Like for example, how to actually evacuate people before landslides. Most important aspect is check for the glacial melt, the pace of glacial melt. Second one, stress along the glacial lakes. Third one, if it is because of the heavy rainfall, then check for the parameters of pressure. Okay, what is the degree of low pressure and what is the degree of like humidity in the region, and several other meteorological factors, and check what can be the predicted rainfall in that region, and accordingly take the disaster management steps. So to do all these things, improve the community preparedness and all these things, you have to actually invest good amount in the early warning systems and disaster preparedness. And thirdly, look for nature based solution. That's where I said traditional knowledge should be respected. Okay, so like promoting greater amount of afforestation that is native to that region. Don't bring some species and plant it. Bring the species that is native to that region, so they have greater strength, right? Okay, and also better watershed management. Degraded ecosystems, degraded land should be restored. Okay, so stabilize that ways you can stabilize the slopes, reduce the landslides. Okay, moreover, address the climate change. Address the climate change by coping up to the expectations of the ecosystem. Bring homeostasis in the Himalayan ecosystem. That will also address the climate change. Okay, so when you address the climate change, eventually Himalayan ecosystem is less prone to landslides. Okay, similarly, promote regional cooperation, because there are countries, Bhutan, Nepal, India. Okay, so these, like, Himalayan countries should work together, share the data, knowledge and resources, and make sure this will be a foundation step for effective disaster reduction. Okay, and also you have to promote community participation and raise awareness amongst the locals by educating them to fight against the unsustainable practices and unsustainable development in this region. And moreover, we should also bring policies and governance where we enforce very strictly according to the need of the hour, and make sure there is strong environmental impact assessment in the region. Okay, and all these, along with that, the role of science plays a bigger role or bigger aspect. We should make sure these complex interactions are monitored, and, like, accordingly the steps are taken by proper research and development. %100. Hmm. 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 Right. Hmm. Yes, it is helpful. Yes, of course. See, when I say, like, you bring the early warning systems, that is the immediate, like, what do you say, just before the crisis. But there is also, yes, long term. Yes. So that's where I said we have to go for research and development. Yes. Okay. So that is the thing. Okay. So here, when you look at, these are some of the important aspects that you see regarding this particular topic. Okay. So any doubts in this? Anyone? Did you understand holistically how they are interconnected? I hope you understood both the topics clearly. Okay, so I will give you a handout that will be put on your portal. Okay, so I have the handout, little bit small corrections I'll make and I'll send it to you. Okay, so I guess you have the masterclass for environment tomorrow, right? Okay, chalo, we'll meet tomorrow. Okay, yeah, thank you.